Hi everyone, and welcome to this video for PROG1198. In today's video, we're going to start the process of creating a client-side application that can connect to and display data from our database. So we're at that point in the course now where we have created the database, we've set up all the database objects, and now we're going to put it on another hat, so to speak, and create the client side. So this is going to be about creating the user interface that can display the records from the database, as well as performing create and read and update and delete, or CRUD, actions on the data. So let's get started. We're going to create a UWP application that connects to our database. In order for us to do this, we need to use something called a connection string. And a connection string is a way for us to describe in our application how we connect to the database server. So we use that connection string to describe things like the name of our server, the database that we want to connect to, and our credentials and other security settings. And we need to configure our UWP app to pass our credentials to the database. And we want to make sure that we're doing this in a secure way. Another thing that we need to do is to create a code library which interacts with the database for those CRUD operations: create, read, update, and delete. And then our UWP user interface is going to interact with the code library. So what we end up with when we're all is said and done is a 3-tier architecture. So this is one of the ways that we can create a system that has multiple levels. So on the left here, we have a circle representing the database. So this was going to be our SQL Server database. And on the right is going to be our UWP app. And in the middle, we're going to have this business layer or data layer that controls how the user interface interacts with the database. So it provides another layer of abstraction and security so that we can use our database with multiple different user interfaces, or we can change our user interface to work with multiple different databases. We have this level of abstraction in between so that our user interface doesn't directly know anything about the database. All it knows is calling methods from the business layer. And the business layer handles the details of how the actions actually take place in the database. So it provides us some additional levels of abstraction and security. So we're going to start by creating the business layer. We're going to create a class library for Universal Windows. And in this library, we're going to create classes for each database table or object that will be used in our app. Now, during this example, I'm going to use our company database. So just as a reminder, this is what the company database looks like. We have 2 tables and a one-to-many relationship between department and employee tables. So when we create our business layer, one of the first things that we're going to do is create 2 classes, one for departments and one for employees. And we're going to create the classes to reflect the types of data and the fields that we have in these tables. So we're going to make a department object that has those 3 properties: department code, name, and budget. And then we're going to make an employee object class as well to reflect the employee data. When we get further on into the course, I'll show you how we can make our objects work with the one-to-many relationship. But for now, when we get started, we're just going to treat them like 2 separate objects. So I'm going to start by creating a new project. And we know that we're going to need 2 different types of projects that work together, one being the class library and the other being the UWP app. So it doesn't matter which one you start with. I'm going to put them both into the same solution just for simplicity's sake. Then I don't have to worry about constantly updating the references every time I change something. But just so you know, you can put them in 2 different solutions as well. So it's up to you how you want to structure your project. So I'm going to create our class library project. So when we create the project, I'm going to give it a name. I'm going to call it company library. But the solution, because it's also going to encompass not only the code library, but also the UWP. I'm just going to call this entire thing company solution. So we'll create that. And then we can get to work building our classes for department and employee objects. So when we make these classes, they're going to start off very, very simple. And we're going to kind of abandon some of the rules that we know that classes have to follow. Like, for example, we want to write constructors, we want to override toString, all of those rules that we've learned in our C#. We don't abandon those fully, but they're not relevant to what we're doing today. So I'm just going to write the parts that we need for representing our table objects in code. And, I've put in a note here about improving these classes later. So to keep things simple at this stage, we're going to keep everything public. I'm just going to have some public properties here that all have get and set accessors. So you can see the two classes that I've created, employee on the left and department on the right. I'm using the exact same names for the fields here as our fields in the database table. Now you can choose to use different names, but it complicates things for us down the road. So the easier thing to do is just to give your properties the exact same names, and spelling counts as well. Capitalization, it's case sensitive, as all of the fields in our table. And as far as data types, you just want to pick the closest possible match. So fields that are char or varchar or nvarchar or any of those text fields in the database, we want to replace those with a string data type in our C#. Decimal data types can be transferred either to decimal or double, depending on the size that you need. Dates and times can both be put into a date time object. So you want to match the data types as closely as possible. If you choose a data type that it can be converted to, then you won't have to explicitly do data type conversions. So that's something to consider. So I'm going to take these two classes and put them into our code library. So here's my project when it opened. I started out with a Universal Windows code library, and we know that it gives us this default class called class1.cs. So I'm going to start off by just renaming this file. Now, in the past, what we've done in other courses is to create a different class file for every class that we create. So you're welcome to do that, or you can put multiple classes into one file. Now, what I'm going to do here is I'm kind of going to take a hybrid approach to that. I'm going to write the classes that represent my tables all in the same file, and then I'm going to put all of the database access stuff into a different class file. If you prefer to have separate class files for each class, you are more than welcome to do that. So I'm going to rename this one to table objects. Remember, that's just the name of the file. It's not the name of the classes. So I don't need a class called table objects. I'm going to instead create a class called department. Now this is the exact name of our table. And then we create a property for each field in the department table. So as another reminder, we have dept code, dept name, and dept budget. String, string, and decimal. So I'll just pause the video while I type those in. So here are the three properties. In the future, we're going to come back to this class and add other things. For example, one of the things that we might add would be a collection of all of the employees in that department. Or we could add a constructor for us to create new departments in a more streamlined way. So there's lots of changes that we can make to this, but for now, we'll just keep it simple. Now, just underneath the department class, I'm going to add the employee class. We want to make sure we're keeping our classes public so that we'll be able to access them from the other project when we create our UWP user interface portion of this. And we'll just create the same sort of thing. We can create data types that reflect every field in the table. So in the employee class, we're going to create our properties for employee objects as well. So I'll just pause the video while I type the rest of this in. So here's our employee class with all the fields in employee. So once we've finished this, we can move on to the next step of creating our code library. The purpose of the code library is twofold. The first is to represent the objects in the database. So we've done that. And the second is to perform database actions. So we're going to write another separate class which performs database actions. The class has two jobs: to make and maintain the connection to the database. So connect to the database and maintain that connection. So we need to store our connection somewhere. And the other job, of course, is to perform queries against the database. We're actually going to send select queries, insert, update, and delete queries. So we're going to create a class that performs both of these options. When we're writing the connection, we need the following things. We need a private IDB connection object. So we're going to use a code library that creates some sort of database connection that implements this interface called IDB connection. And then we're also going to create a constructor in our class that takes a connection string and creates the SQL connection. So SQL connection is just one type of database connection. As you know, there are other types of databases out there. But for us, because we're creating a connection to SQL Server, we're creating an SQL connection object, which is one of the objects that implements IDB connection. So when we create a new instance of this class, the constructor is going to receive the connection string and connect to the database. It's important to note that we don't store the connection string in this class. This class is designed to be a bridge between the user interface and the database, and as a bridge, it does not hard code which database it goes to. So it becomes interchangeable that we could use it with different databases by creating the class with a different connection string. Now, if you want more interesting info about connection strings, I've provided a link in the slides here to a description of how connection strings work. I'm going to show you an example that most likely will work with your home system setup because it uses pass-through authentication. So if you have permission in Visual Studio, you should be able to pass that permission through to SQL Server. And there are other types as well. If you are using Windows authentication in SQL Server, it becomes really simple. If you are using SQL authentication, then you'll need to provide your username and password. Typically what you would do would be to create a user that has restricted permissions on your database and then provide that username and password as the user that your application uses to connect. Regardless of what your connection string turns out to be, just keep in mind that we're not storing it in this class. So when I create my next class, I'm going to give it its own file. In order to keep it separate from the object classes here, I'm just going to add a new class. And I'm going to give this class a name that represents the entire database. So in this case, our database is called company. So I'm going to call this thing company as well. It doesn't matter too much what you call it. A lot of times online, you'll see this called something maybe like repository is a common one. But in order to indicate what it represents our connection and usage of the company database. So we're going to add this class as a new file. Now, before I do anything else, I want to make sure I add this public identifier here so that we can make sure that this class, so we want it to be accessible from the other library. Once we've done that, we will create our IDB connection object, and we want to keep this thing private so that other classes can't mess with it. Now, when we create the IDB connection, and I'm just going to call this thing DB to represent our database, you'll notice that I don't have the reference to that possible type or namespace. But we can resolve the reference pretty easily. Actually, if you just mouse over this little thing, it recognizes that we need to add a using statement here. So if we add this using statement for system.data, then it brings our IDB connection interface into scope. Another option is you can just declare it directly like this. If you don't want to add the using statement for whatever reason, you can reference it that way as well. But I think it's a little bit cleaner to just insert the using statement that we need. That's typically what we do. So we've declared our database, and now we want to create the company constructor that sets up the database, which means we're going to create that new connection to our SQL Server. So we take our connection string as an input parameter, and we use our connection string to set up an SQL connection. When you set up the SQL connection, again, we're missing a reference, so we'll do the same thing and we'll resolve that reference here. The namespace that we need, system.data.sql client. So we've got that there, and now we can set up an SQL connection object. The input parameter is the connection string. And we're going to talk more about connection strings and what they are and what they do when we get to that point in the lesson. So our next step is going to be installing the framework that simplifies our database access. Now, we're not using it quite yet, but this is the last step in the setup for the code library. So our code library is going to be how we access and send queries and retrieve data from our application to our database. And there are several different ways to do this, but the Dapper extension is one that really simplifies it for us. So this is adding a reference to another code library that's available through our NuGet packages. So this is just similar to adding a reference to a code library that we wrote, except instead of adding the reference to a DLL from our local system, we're going to be installing the reference from the internet using NuGet. So Dapper is a nice, very concise, very easy to use framework that provides methods that we can call that send queries and retrieve data. So we're going to install this as part of our project. The way that we do this is by adding the package reference using our NuGet package system. So we right-click on the project. Now the project is the one that's highlighted in the screenshot here, not the solution, but the one underneath it named library at this point. And we're going to right-click, choose Manage NuGet Packages, and we're going to go into Browse and look for the appropriate package. So let's find this here. I'm going to right-click on my project, and we're going to go into Manage NuGet Packages. So by default, what it shows you is the packages that are already installed in this project. You can see that the Universal Windows Platform .NET Core package is installed because I chose Universal Windows Library. If we want to get new packages, we can click here on Browse. And I'm just going to search for Dapper. So we search for Dapper. Look for the main one here. There are other extensions to Dapper as well, but we just need the main Dapper library. So we are going to click on that. And over here on the right, we're going to click Install. We're just going to click OK to the dialog that comes up. It's warning you that it's going to make a change to your solution. That's great. That's exactly what we want. And it doesn't take very long. So once that is complete, we can just close the NuGet Package Manager, and you'll see the reference to Dapper is here now in our company library. Now, inside this package, we can't really open it up at this point, but inside this package, it contains all of the methods and different objects and actions that we can use to interact with our database. So we're going to bring it into scope in the using statement, using Dapper. Okay, now this class is all set up to connect to our database, and we've installed the library that we need to interact with our database. So the next step is to write methods that represent queries that we want to take against our database. So we need to determine what kind of actions we want to be able to take with our data, and we're going to write a method that performs each one. So we're going to write a method that we can call to insert a new record, or delete a record, or list all the records. You can see I've put some examples here. And you might notice that these examples correspond to the standard stored procedures that we learned a couple weeks ago. So if you remember, we had written all those procedures to perform these actions: list all records, find one record, add, update, remove. Where we're headed in the future is to have our business layer call on our stored procedures. But before we get there, we're going to work just with simple SQL queries, like writing a select query in our project. Now keep in mind that we would need separate procedures for each database object too. So if we're going to list all records, it means, list all departments might be one of the methods that we have, and then we might have a different method that lists all employees. We might have a method to add a department, and then we'd have a different method to add an employee. So all of our methods would correspond to an action that you can take on one type of object. Now we're not going to write them all in today's lesson because it would be a little bit too much. So what we're going to do today is just focusing on writing a select method that allows us to display information from the department table. We can always go back later and add or modify some of these methods to increase the number of actions that our class can take. When the methods are complete, we're going to build the library into the DLL file, and then we're going to start moving into the UWP client. So let's go into our class and add one of these methods. So I'm going to create a method to start out that will display one department for us. So in our company class here, I'm going to create a new method. We want a public method, and the data type that is going to be returned by this method is going to be one department object. So we're going to use our department class to, we're going to generate a department object based on the results from the query, and then we're going to return that to the calling location. So we're going to give our method a name that makes sense. If you think back to when we learned about standard stored procedures, we know that we have to give methods like this a good descriptive name so that we indicate exactly what it is and what it does. So I'm going to follow along with that and call my method get department by dep code. So something very descriptive and obvious. Now what we need here is, if we're going to pick out one department, how do we decide which department we're going to display? Well, we're going to send it a department code, and it's going to find for us the department object. So if we have an input parameter called department code, we're going to run a query that does something like this. So we need something called, we're going to declare department code as a char for, and we can set it to whatever we want, something like this. And the query that we're going to perform is a select query. We're going to select everything from department where the department code equals our parameter. So if we were to execute statements like this, you can see how we can retrieve one department record or one department object based on the value of an input parameter. And if we change the value of the input parameter, then it's going to change the resulting object. So we're retrieving one object given a department code. So that means our method needs a department code as an input parameter. Now again, I'm naming the parameters the exact same name as the field. Okay, so I'm going to take our SQL statement that we wrote here, copy it, and store it in a string. So the select statement that I want to execute is the exact same type of select statement that we would execute in SQL Server. The only difference is now we don't have to run the declare and the set because depth code is going to come from here. When we perform the query using the Dapper query method, we're going to pass this string, and we're also going to pass this parameter, and it's going to return for us the one single department object. So here is the bit of code that performs that magic. We're going to say DB, that's our database object that represents our connection, and we're going to call its query method. Now, query allows us to specify a data type for the type of results to return. We know that this select statement returns a department record, right? We tried it out in SQL. It returns one department with a dep code, a dep name, and a dep budget. So we're going to specify our matching department data type. Now, when we call this, there's a bunch of overloads. The first thing that we can send is a command, but if we look at the next overload, we can send our SQL string. So that's what I'm going to send as the first input parameter, our SQL string that we defined. Now you don't have to save it separately. You could type your select statement right in here like this, etc. But I think it's a little bit cleaner to store it in a variable. All right, now our next parameter indicates the list of object parameters. So when I say parameters now, I'm talking about these SQL parameter objects. So I'm going to create a new list. So it sends it as an array of input parameters that go to this query. Now it only has one, so I just have to specify the variable that holds the value for this input parameter. So this executes the query saying, perform this SQL statement, and here's the value that we want for the parameter. So you can see how keeping the name the same is simplifying this whole process, because the name of this variable is the same as the name of the input parameter, which is the same as the name of the field. You keep it the same, it becomes very easy. Now, we know based on the way that our department table is structured that this is only going to return one record. However, because you can put any select statement you want in here, it's possible that your select statement might return more than one record in general. So we're going to tack on this extra method that says single or default. And that will ensure that we only get one result. Because if we get multiple results, then we're going to have trouble converting it to one department. So we tack on single or default whenever we're only expecting to get one record as a result. Now this whole thing is going to return this department record. We're going to store it in a department objects. So what's returned from here is a department object, and we store it here in this thing called dept. So we've got this one object that refers to the object that was retrieved from the SQL. And now all we need to do is return it. So calling this method, specifying a department code, gives us the associated department object from the database. The conversion happens thanks to Dapper. So this query method comes from Dapper, and it allows us to convert the results into this department object without us having to explicitly do it. That's why the department object needs to have the field names that match the names of the fields in the database, because then the conversion happens automatically. Now, I can show you some alternate syntax. What happens if your input parameter doesn't match the parameter in the SQL statement? What we would need to do, instead of just specifying the name of this, is we would need to specify how they relate to each other. So let's say, for example, instead of having our input parameter named depth code, we would have the input parameter named something else. Say we called it decode instead. So we need a way to specify that the decode string is going to be used for the depth code in the SQL. I'll just comment out this version. It's almost the same, but the difference is in here how we would assign the parameter value, because you can see that this no longer exists. The name depth code doesn't exist. So what we would say is that depth code equals decode. So this assigns the value of our parameter to the value of the SQL input parameter. So you can see that we are allowed to name our parameters different, but it does create an extra level of work and complexity. And there's really no need to introduce that extra level of complexity. So I'm just going to switch that back to the way it was before. I'll leave this commented out in here so that you can see both when you download the solution. So we're just going to do that one method for now. We will tackle the rest of these examples in future classes. So now that our method is complete, we're going to build our library into a DLL file, and then we're going to move on to create our UWP client application. So we're going to create a new project, blank app, universal windows, and we need to make some changes to that project as well. So let's go back to our solution. I'm going to make sure that we build this. The build succeeded, that's good. And now I'm going to add a new project to my solution. That is our UWP user interface. So we're going to choose blank app, universal windows. We'll click next. We need to give it a name. I'm going to call it company UI, because this is the user interface. Okay, so now that we have our user interface, this is familiar to us. We have our XAML code and all of the parts that work with the UI. The first thing that we need to do is make sure that we set this as the startup project. So if we try to run this solution right now, because we created the class library first, it would try to execute the class library. You can see you get this error message that it says we can't run a class library. So what we need to do is we need to go into our UI project, right-click on it, and set that as the startup project, so that when you click the start button, it actually starts the UWP app, not trying to start the class library. The next thing that we need to do is configure this app so that we can use that SQL Server pass-through authentication. So we want to be able to give our app permission to authenticate using Windows authentication so that we can connect easily to our database. So what we need to do here is we're going to modify the package apex manifest file. So we can find that file in our project, and we just double click on it to open it just like any other file, but it provides for us this interface to change the settings of the project. So right at the bottom, you can see the package. We can open that up. And you can see that there's lots of things that we can change about the project. This might or might not be something that you've encountered before, but this is changing the metadata about your project. So you can provide a name for your project, a description, supported rotations if you're using this on a mobile device. There's all different kinds of things that you can change about your project. But what we're interested in is changing the capabilities. So system features or devices that our app can use. And we need to authenticate. So we're going to check off enterprise authentication. So it says here that it provides the capability to connect to enterprise internet resources that require domain credentials. So this allows us to use that pass-through authentication. So once you've checked that off, we're just going to save the manifest file and then we can close it. If you're trying to connect to a SQL Server database and you're constantly getting your connection rejected, that is the most common thing to check for, that you forgot to enable enterprise authentication. So make sure that you do that right when you get started so that you don't forget to do that in your project. Now, our next step is to create the connection string. Now, we need to store our connection string in a secure location. We don't want to put it on the main page because that page is, accessible to users and they might be able to view the source code. So we put it into a location that is protected, and we're going to put it into this file, app.xaml.cs. It's a protected location, and we're going to write a read-only connection string property that provides access. So let's take a look at our code behind for app.xaml. So we go into here. This is where we're going to define our connection string. So I'm going to create a connection string. We'll put it right at the top here at class level. So I'm going to declare it as private and as static. We want to share one connection string across the entire application. Give it a name and assign it a value. So I'm going to use this @literal to make sure that our connection string isn't subjected to any escape characters or anything like that, so that we can use backslashes and things that we need to. Okay, so for Windows authentication, the data source is going to look something like this. So we say data source equals, and then we provide a path to our database management system here. If you don't know what your server is called, then the way to do it is if you just go into SQL Server Management Studio. Most of the time by now, I think we just bypass this window. We don't even look at it anymore. We just hit connect. But this is where you get the information for your connection string. So if you're using Windows authentication, you can use that same server name. So I've got /SQL Express. If you've got something different here, then that's what you put in here in your data source. So we say data source, there's a space here, and then equals, and that is the name of your server. Then we put a semicolon. The next thing coming up is what database you want to connect to. So this is the connection to the server. If you're using Windows authentication, then we're going to use something called integrated security. When you click connect, the next thing you're interested in is, well, which database are you going to use? So we can take a look at what the name of the database is, and we're going to put that into the initial catalog. So again, watch your spacing, watch your formatting. We say equals, and then the name of the database. in my case, the name of the database that I'm using is called username_company. If yours is different, put in the name of your database. And finally, I'm just going to hit enter here so that we don't go off the side of the screen. The third piece that we need for Windows authentication is passing through the credentials. Integrated security equals SSPI. Now, if you want to learn more about the different types of security, just click on that link that I provided in the slides that explains all the different parts of connection strings. There are lots of different ways to format connection strings, and there are lots of different pieces of a connection string that have aliases. So, sometimes you might say initial catalog, and sometimes you might see a connection string that just uses the word database there instead. So there's a lot of different ways that you can build it, and that link outlines a lot of them for you. So if you want to find out more and you want to change your connection string, or if this isn't working for you, then you can look into that. Or of course you can ask me to help you out as well. Now, if when you connect to SQL Server, I'll just bring up that connection window again. If you are using SQL Server authentication and you're providing a login and a password, then that information is going to need to be provided in your connection string as well. So I'll do an example of a connection string using SQL Server authentication too. I'll just pause the video while I type it in. So I've pasted the connection string in here that is used for SQL Server authentication. You'll notice that I'm still using data source and initial catalog. In here, that is the name of your server and your instance. You can see I've got ./SQL Express. We could use that here as well. You can get this information from your version of SQL Server Management Studio. And then over here, instead of integrated security, we have user ID. That's where you put your username, and then password, and this is where you type your password. So that is what the connection string looks like if you're using SQL Server authentication. And personally, I'm using Windows authentication, so I'm going to get my Windows authentication connection string back. Now, because it's private, obviously I'm not providing any access to it, so I'm going to create a public property that exposes this. I'm only going to write a get block. I don't want to be able to change this value from anywhere ever. The only way to change it is by coming into your app and hard coding it in. Now, there are other ways that you can do this, storing the connection string in like a XAML file or in an XML document, or in other places. You can store it in files or online, but this way is the most reliable way that I've found that is going to work for everybody. So let's make a public property here. And we can expose that in a get operation. So you can see when you do it this way with the arrow notation, it provides a get without a set. If you don't like the arrow notation, you can always write something like this that is just a wordier way of saying the exact same thing, where we have a get block that returns it. Notice there's no set block. Okay, so this is our Windows authentication connection string. And then this one down here is SQL Server authentication connection string. Okay, so now we've got our connection string. We have the means to provide the connection. If you'll remember from before, when we provide that connection string to our company class, that is what allows us to actually make that connection to the database and store the connection object, and then we use the connection object to perform queries. So now that this is all set up, all that's left to do is actually make the UWP app. So what our goal is for this version of the UWP app is we wrote a method that takes in a department code and returns a department object that matches. So we need to make our user interface be able to work with something like that. So my goal here is to have the user enter a department code, and then we can display the information about that related department. So if we're going to have the user enter something, we're going to need a text box for them to type it into. We can also make a button so that they can say, find this department, go, search, whatever we want to call that button. And then we're going to put a text block underneath that displays the name of the department that we found that matches that department code, just to prove that this whole thing works and that we have the ability to retrieve data from the database. So I'm going to create that user interface in just a minute, but first, we need to consider the fact that we're going to need to have the ability to create the company object so that we can call the methods. So we need now to add the reference to our class library file in this project. We include the using statement to bring our class library into scope. So you can see the using statement up here. And then we create an instance of the class that represents our database. In our case, we've called it company. That's the class that contains our query action methods. So we don't need to create an instance of department or an instance of employee just yet. For now, we want to create an instance of company. That is the class that creates the connection to the database, and it's also the class that has all of those methods that we're going to write that allow us to perform the SQL queries. Okay, so let's put that into our code. I want to add the reference. So in here, we know that we can add a reference to a class library. There's a bunch of different ways to do it. You know, you can right-click on references, or you can right-click on the project itself to add the reference. By default, it looks in this same solution, and you can see it already sees it here in company library. So I'm just going to check that off. You can do it the other way too, that we've learned in your other course, where you browse and find the DLL. For this case though, the reason why I'm keeping them in the same solution is because it automatically refreshes. If I have two separate solutions and I go and change something in the library, then I have to copy the DLL and remake the reference every time. So that can be kind of a pain, especially during demonstrations like this where we're constantly changing things. Typically, what would happen more likely in the real world is that it's completely different teams of people, the people doing the user interface and the people making the code library, and the code library people say, okay, here's a good stable build, let's pass it on, we're going to make it publicly available. And then the other team just takes it and runs with it. And it's not, constant back and forth updates, right? But when we're practicing and when we're wearing both hats, it is constant back and forth updates. So that's why I've chosen to just put them in the same solution, and we can maintain the reference that way. Okay, so I'm going to click OK. And now we've added the reference to company library. And I'm going to go into my code behind here and bring the library into scope. So this is my main page code behind, and we're going to say using company library. Okay, so our company class, that's this one. That's the one that creates the database and then performs the query. We need an instance of this class, and we're going to pass our connection string over to that instance. So I'm going to create a new company object. So I'm saying create the database object because company is the class that represents our entire database. It represents the connection as well as all of the query actions that we can take. So we're going to make our database object. However, I'm going to declare it at class level because later, when I create that button I was talking about to perform the search, I'm going to have an event handler method for the button. I want to be able to access the database everywhere. So I'm going to declare it at class level as private, as static, and its data type is company. And I'm going to use the same name even, so we'll call it DB. when we create it, when the page first initializes, we're going to call the constructor. Now the constructor that we wrote is expecting us to pass the connection string. The connection string is stored here in app.xaml.cs. So we're going to look in the app class for the connection string property. App.connection string. Okay, so that creates our company object, and it allows us to make that connection. Okay, now we're going to go in and we're going to test our access by calling that method to display one department. So we're going to create our user interface, the text box for user input, the text block to show the results, and the button, and then we're going to make the button click event. In the button click event, our goals are find out what they entered in the text box, call that method to retrieve the associated department, and then put the resulting department's name into the text block. So we're going to create a very simple user interface for this input-output cycle. So in our main page, I'm going to put a text block and a text box and a button. So I'll just try to organize these a little bit more nicely here, and we'll get a button. We want to make sure these things all have names so that we can access them in the code. So the text block, we can call that thing LBL output. Actually, that's a little too generic. I'm going to say LBL department name. And for the text box, we're going to give that the name TXT department code. And for the button, BTN find department. So good descriptive names. I'm going to change some of the contents as well. So we can have the button say search. I'm going to take the text out of the text box, and the text block, I'll just put in some kind of generic department name placeholder here. So obviously we know that the user interface needs work to look nice, and it needs some user input prompts and whatnot, but this will work well for our purposes of the demonstration, which is not necessarily about how great this looks, but it's about the fact that we can access the database. Okay, so let's double click our search button to get our event handler. Now, our goals in this event handler are to get the input from the text box. It should be a 4-character department code, like ACCT, for example. And then we're going to call the method. What method are we calling? It's in company get department by dept code. We're going to pass in the department code from the text box. It's going to pass us back a department object that matches. So we're going to call that method to retrieve the department object, and then we're going to display the department name in the text block. Okay, so we have a plan. Let's code it up. Getting the input from the text box. The department code is our txt department code.text. All right, step 1 is done. Calling the method to retrieve a department object. Well, we're trying to retrieve a department, so I'm going to create an instance of department to store it. And I'm going to call the method from company. Now remember, our company here is called DB. So we're going to go db dot get department by department code. We're going to pass in our department code parameter that came from the text box, and it's going to give us back this department object. Finally, now that we have the department name, we can display it in the text box, text block. So we're going to take our department object dot, and you can see the properties. So these are the public properties that we created that make up that department object. So we want to take the name and we're going to put it into the text block. So this is going to be the moment of truth, running it and making sure that it works. Now, sometimes this happens. You'll see that when I chose to run the project, you can see down here it says it skipped my deploy. Now the reason why that happens, sometimes this happens if you create the code library first, which is what I did this time around. You might have noticed this in your travels, that when you create a code library, it creates this configuration for debug on any CPU, because the code library is meant to run on anything. However, when we then add a second project, and it's a universal Windows app, sometimes the configuration doesn't get updated. However, you can't build a UWP application on any CPU. You actually have to choose a platform. So when that happens, what happens instead of it, failing to compile is it just skips right over it. So you try to execute it and just nothing happens. Now, the solution to this, and I put it in the slides at the end, so I'll just skip through. If you get your build skipped because of different target platforms, here's how you can fix it. There's a list of steps here, and I'll just display them for you. So we're going to right-click on the solution. So way up at the top, the root of all of these projects, the solution, we right-click, and we're going to go into the configuration manager. And you'll notice the different platforms selected and how the UWP user interface portion of this is not selected to build or display because we're working on a different platform. So the way to solve this is to make sure that the platform for the company UI project, that's your XAML, your main page user interface project, whatever that is, change these other ones to match. Now, you might not be running on x86 if you're using a different kind of system. You might be using a different platform. That's okay. As long as they're all the same, then that's all you need to do. So once those are all the same, then we can just click on close there. And when you run your project, it should all build, compile, and run. So I'll just pause while this thing builds and loads, and then we'll verify that it works. Okay, here's my project, my text box. It's all ready to run. What I want to do here is enter a department code. Now, in order to avoid breaking it, I'm going to make sure that I enter a valid department code that does appear in the table. And when I click on search, you might have to be patient for a minute, but you can see that it retrieved that accounting value from our database table. And if I do it with a different department code, then I get the name of the associated department. So we have successfully connected our UWP application to our database data. Now, this works great when you enter a department code that does exist. If you enter anything else, you have to be prepared to respond to errors. So you'll notice that it didn't retrieve a department. I put in a department code that was not in the database. This thing is null, so then I try to display the name of a null department. I get an exception. So your next step in a project like this is to not forget about all of the other C# important concepts that we have learned. So user interface design considerations. You can see that I only built about half of the interface that's displayed on this slide. We need prompts, we need user feedback, we need things like that. Validating the user input. I didn't do any of that. What if the user doesn't enter a department code, or what if they enter something that isn't a valid department code? We want to make sure that we try to do validation on the client side as much as possible, because yes, if we send bad data to the database, it will respond with an error. But if we can avoid sending bad data to the database in the first place, that's better. So we want to try to capture as many errors on the client side before calling that method that goes to your database, if possible. If we know that department codes are supposed to be 4 characters, or we know that they can't be null, then why pass those to the method? Just stop it here. So another thing, try, catch, and error handling. That really could have helped me, in this situation. I could do a quick little if statement that says if department is null, we're going to display an error message. Now we can also implement try, catch if the database method itself throws an error. Now the way that I wrote this method, there is no validation or error handling in this area. So if we send something to the database that, say for example, we don't have a department code at all, we're going to get an error thrown here. So we might even need to back up a step and put a try catch into this method so that it will throw an exception if something goes wrong with the query. And then we can, when we call the method, put this in a try catch so that we can actually respond to that exception in the user interface. So we'll look at that in a future video. So we've accomplished everything that we set out to do today. We were able to make that three-tiered architecture between the database, the data layer or the business layer, and the UWP user interface, where each one has its own role that is separate but related to the roles of the other parts of the system. We were able to successfully create a connection to a database and obtain input from the user that allowed us to pass that input to the database, perform a query, retrieve the results, and store them as objects in our application, as well as displaying them to the user. So we will build on this in the coming weeks of the course, where we're going to add more methods to perform the rest of the CRUD operations. So looking at creating, updating, and deleting. We're also going to look at building collections of objects so that instead of getting one department, we can get all departments and display them, say in a list, for example. And we're also going to look at how elements can be related to another. So for example, if we have a department object, could it come with a list of employees who work in that department? And we can store them all together. So those are some of the things that we can look forward to in the upcoming weeks of this class. Until then, if you are trying to code along and build something like this at home, if you encounter any problems or issues with your connection string or something's not working in your app, make sure that you reach out to me or drop into any one of the 4 Collaborate sections that happens during the week. And I'll be happy to help you debug and get it working so that you can connect your app to your database. So I hope you all have a great week, and I'll see you next time.